position vectors here, right? Next is position vectors. All these definitions you will remember, right? Suppose you are standing in a field, right? Where you are standing at is the origin. And then stretch your hand, right hand, that is x-axis, and this is the y-axis. Right? Where you are standing at, that is the origin. The origin is the position where the observer is standing at and is studying about the motion of your body, right? Or you stand at the corner of a table. One side of the table is considered x-axis, other perpendicular side is taken as the y-axis. You are standing in the corner. That corner is the origin, right? On the surface of the table, suppose a small object, an insect is moving over. At any instant, when you open your eye, the position of that particular object is fixed at that place, right? That only I am doing here now. See, suppose this is one side of a table and this is another side of a table. This is the surface of the table, plane of the table, right? This point where you stand at is the origin. This is x-axis and this is y-axis. As you know, the fact that to study the motion of a body, we take the help of two axes, what is a coordinate axis to study about the motion of a body, right? So without having these two axes, we cannot study about the motion of a body, right? This coordinate system is necessary for studying about the motion of a body. So you are standing at this position, and when you open your eye, you see an object is lying at a point in the plane bound by these two axes. Which are the axes? X-axis and y-axis. So the practical condition is very simple. You are standing at the corner of a table, and that is the origin, right? And you are looking on the plane of the table bound by x-axis and y-axis, and find a small little insect is moving on the plane, right? Then fix the position of that object and draw a line, straight line to the origin, and put an arrow mark here. And you will write this is vector r. This is the position vector of that object at that particular instant. So position vector of an object at a particular instant is a straight line joining the position of the object to the origin and put an arrow mark at that point. This is the position vector of that object at that instant, right? Okay. So position vector is very important because using position vectors, we can calculate the displacement of an object. Displacement, if you know, then velocity of the object can be calculated. If velocity we know, acceleration also can be calculated because displacement is rate of change, velocity is rate of change of displacement and acceleration is rate of change of velocity. So first of all, you have to calculate the displacement. Knowing the position vector of an object at different intervals, different instants, we can calculate the displacement of the body, right? This is the suppose that initially when you look at an object, the position vector is given by vector r1. After some time, the object has moved to some other places. Suppose that time the position of the object is here. Now the final position vector is obtained by drawing another straight line here with an arrow head here, right? This is what is called vector r2. Vector r2. Am I correct? So now this is this was the initial position A and this is the final position B. Then this is the displacement of the object. What is displacement? Vector AB is the displacement of the object, right? Vector AB can be obtained from this one. We can write vector AB is equal to final position vector minus initial position vector. The displacement can be calculated. So position vector is very important. Position vector is nothing but it is the straight line joining the position of the object in the plane to the origin. Put an arrow mark at the end. That is represented by vector r. Initial vector position vector is r1. Final position vector is r2. then the displacement of the object can be obtained using these two position vectors. How? Displacement vector AB. Vector A means A to B, that vector is called vector AB, is equal to final position vector minus initial position vector. So this is about position vector. That is very, very important. And also displacement vector also we have seen. Displacement vector is nothing but it is the change of position of a body in a straight line. The shortest distance moved by a body between 2 points is called, it's a displacement vector. In this case, displacement vector is AB. The body can move along this direction also and come to this point. It can come to this is path number 1, this is path number 2, and this is path number 3. Right? Okay. Displacement is actually the shortest distance. The body travels a long distance through this curved line and reaching at the point B. But displacement is between the final position, the shortest distance traveled between 2 points is called displacement. See, displacement is a physical quantity. That is a vector quantity. Displacement is actually a fundamental quantity. That fundamental quantity is a vector quantity, right? So this is about displacement vector. Then is coplanar vectors. Coplanar vectors means vectors lying in a plane are called coplanar vectors. Coplanar vector, I am going to write. Coplanar vectors are vectors which are lying in the same plane. Same plane it is, right? That is called position vector over. Next is coplanar vectors. Coplanar vectors are vectors lying in the same plane. Suppose two objects are moving in the plane in two different directions, right? One body is moving in a certain direction in the same plane itself, other body is moving in the same plane in other direction. So the displacements produced by these two vectors in a fixed interval of time, they are coplanar vectors because the bodies are getting displaced on the same plane itself. Right? Two bodies are kept on the surface of the table, and with your hand, some force is applied on that. That means the force is acting on the body in the same plane itself, and the bodies are getting displaced or accelerated in the same plane. Then these two vectors can be studied to be coplanar vectors. So coplanar vectors, it is defined as those vectors which are lying on the same plane are called coplanar vectors. Right? Next is collinear vectors. Collinear vectors are, what I say, collinear vectors. Collinear vectors are vectors which are acting along the same straight line. Two vectors or two or more vectors which are acting along the same straight line are called collinear vectors. For example, this is vector A, and this is vector B, and this is vector C. This is vector A, this is vector B, and this is vector C. All these are joined together. That will form a single straight line. All these vectors which are acting in the same straight line are called collinear vectors. They are called, right? So many things we have studied till now, right? Vectors are quantities which need both magnitude as well as direction. So to add, subtract, multiply vectors, we cannot use symbol methods of algebra, right? But to add the scalar quantities, we can use symbol methods of algebra. So that is the importance of learning this lesson, because in physics we have to deal from the beginning to end. So many occasions deal with vector quantities. We want to sometimes we shall be multiplying two vectors, sometimes we are adding two vectors, sometimes we are subtracting vectors, etc., etc. For this, we must have idea about how vectors are analyzed, right? It's just unit vector. Unit vector is a vector having its magnitude unity is called unit vector. So once again, the vectors having its magnitude unity is called is called a unit vector. Unit vector has an arbitrary direction. in direction will be there. That depends on the original vector, right? Suppose that this is vector A,